Hello there. Thank you very much for joining us today on today's installation CPD. We'll start with just a few little housekeeping notes. You'll see in the middle of the screen there, you've got the three dots for the fit to frame. If you click that, you'll be able to see us in a much better configuration. Pardon me. Good start. In the background will be my colleague Craig. He will be manning the chat. We will have times that we will stop for any questions, but if not, please just type them in the chat and we will answer, or Craig will answer there and then, or we will answer in the end. Okay, let's begin. So today being the second Thursday of the month, we are on the second of the 4 CPDs that Recoup do monthly. Ours is on installation and a little bit of the technology overview. However, we also have CPDs for residential new build, retrofitting and social housing decarbonisation, and non-residential fitting of wastewater heat recovery. So what we're going to go through today, we're going to have a little introduction to the technology, why we use it, where we would find it. Then we're going to go through our product range, our portfolio of items that we've got. Then at that point, we're going to swap over to my colleague James, who's going to take you through some schematics for installation points. We're going to have some time for some points of discussion and any questions that you require. So what is wastewater heat recovery? Well, we start with the wastewater that leaves the outlet, the shower tray. Around 85% of that is completely wasted. Then we feed that through our heat exchanger. Through the bottom of that heat exchanger will go the mains cold feed. The two of those will mix. Heat transfer will happen. So then we can send that preheated outlet that will go from around a 10 degree feed to a 25 to 28 degree preheated feed. We can send that to numerous places, either back to just the shower itself, the cold side of the shower I should say, or the heater. So it could be a cylinder, combi boiler, air source heat pump, heat interface unit. So why would we use it? Well, it has a significant CO2 and energy reduction, especially within new builds. You've got a fairly blank canvas within a new build, so it's going to make it particularly easy to design into. It offers then cost-effective SAP compliance. Don't want to be known as a box-ticking exercise, but New Build 101 is Part L compliance. And when you compare wastewater heat recovery to technologies such as solar PV, pounds per points, we are by far the lowest. But it does have real world applications. It offers huge reductions, up to 55%, in the amount of domestic hot water used per shower, and because you are sending that preheated water back to potentially a boiler, cylinder, your hot water source, it's also then reducing the energy required to produce that water because you're starting from a much higher heat. It is a passive technology. One of the great things about wastewater heat recovery, it cannot be turned off, it cannot be removed, it will always work. 95% of the time, I'd say, the end user won't even realise it's there. As we said earlier, very easy to design in, very few limitations. Basically, you just need an inlet, an outlet, and a cold feed. Long lifespan on the products. Our vertical products have around 40 to 60 year lifespan, which has been published by Bays. Horizontals around sort of 25 years, and a lot of that is because horizontal units haven't been in the market that long. Because it's a simple heat exchanger technology, a copper heat exchanger technology, very, very low embodied carbon, highly recyclable product. We also offer a £75 recycled products for faults back as well. So where would you find it? Well, majority of installations will be on new build residential because of its ease. However, anywhere where there are high levels of shower traffic, it is prime for areas such as leisure centres, sports facilities, hotels and student accommodation are prime for wastewater heat recovery. And also retrofitting with the Social Housing Decarbonisation Fund. We have some great retrofit options. So let's go through some of the products that we offer. So we have two different types of heat exchanger. We have vertical and horizontal. Vertical, because of their sort of gravity nature, are always going to offer a slightly higher efficiency than a horizontal, and potentially be easier to install, especially on a new build residential. So we're going to start with our pipe hex. Oops. So here is the pipe hex as you would receive it. Two boxes, one with the 2.1 meter vertical heat exchanger, and then one which is the ancillary pack. In that ancillary pack, you will find the turbo rotator for the top of the unit. This is a very clever piece of kit that promotes our thin filmed heat exchange, which James will go into a little bit more detail in a little while. You'll also get your waste connections for the bottom, as well as two mounting brackets. Now you'll find the vertical exchanger itself will have an end protector in each end. You want to keep those in until it is installed on the wall, just to protect any ends. And then you'll have your cold water inlet and outlet connectors at one in each end. This is a 1/2 inch BSP thread, so you'll need a couple of male irons to take those to desired pipe size. You want to be careful not to cross thread. It is a plastic on metal connection. You certainly don't want to use any more than 30 Newton meters of force, and then using either a liquid or solid PTFE sealant. Also, what you will get with the box is your SAP label and product registration. These want to be sited near the water heater. Okay, so let's see this product mounted. So here it is, the 2.1 meter floor to ceiling exchanger. So your two mounting brackets want to be mounted around 1500 millimeters apart. We have them there on timber battens. You see there James testing for its, making sure it's vertically level. This is very, very important. Doing this, not putting this level, will drastically affect efficiency. You want to support these fittings when tightening them. Do not twist the exchanger, so using two grips to connect up. You see at the bottom there is the push fit waste outlet connection going into the saw pipe. Okay, let's have a look at some of those connections in a slightly closer. So all wastewater heat recovery installations will require a couple of additional products. You will need two full flow isolation valves, one double check valve to prevent backflow, and a drain off cock or drain valve to drain down the unit if required, as well as your two male irons to your required pipe size. So these valves, we would recommend they go as close to the unit as practically possible to allow for draining if required. Okay. So just going to have a look now at the top of the unit when installing, and have a little bit more of a look at the turbo rotator. Turbo rotator, very clever piece of kit. It effectively rifles the water down the unit to promote thin-filmed heat exchange. This has a 60mm insert for the waste pipe, so you want to glue the whole of that 60mm down and twist in to make sure you get a firm connection. That will obviously therefore take 43mm solvent weld pipe. So as you can see, it fits quite nicely there in within the SVP, and we'll place the boxing over this. This is sort of the most common installation type for this. This extends the SVP boxing to around 385 by 220mm, so around doubles. What you must not insulate the wastewater heat recovery unit. If the SVP is needed to be insulated, then you must segregate it. Right, so just some key points to go through from that. You'll see in the top right corner there is a little demonstration video of how the turbo rotator works, how it promotes that thin filmed heat exchange that really allows, or really heightens the efficiency. You'll see how it clings therefore to the edge of the unit rather than going straight through the middle. Right, so all of our products have a double-walled heat exchanger. This is very important because it allows the trap to be placed where the trap should be, just at the end of the unit. Don't have to go through the wastewater heat recovery unit and then trap afterwards. It also helps, it offers a visual leak detection. If there is a leak or a split in one of the two walls, then the water will literally leak out the bottom. We'll be able to see that straight away. Won't get boxed in. Makes it so much easier. Pardon me. Now, as we stated a little while ago, the wastewater heat recovery must not be insulated. Basically, the wastewater heat recovery unit must be allowed to cool down naturally. So therefore, it must be located within the thermal envelope of the building. Right, so we're going to go on to our next product, which is an upgrade kit for the Pipe Hex. It is the Pipe Hex Active. So what we've done is we've teamed up with Sunny Flow, and added a Sunny Shower grey water pump. So this will allow for same floor installations with the same high efficiency as the Pipe Hex. As you can see, we have the grey water pump which sites near to the shower tray. This then pumps water up to the buffer at the top of the unit periodically, so it allows for a gravity flow through the unit itself, which then allows for the same level of efficiency as the Pipe Hex. Got quite a bit of adaptability within installation. You see you're allowed to mount that pump within a couple of meters of the tray itself with a full, and then that pump within a meter of the unit. As a standard installation, we'd see the Pipe Hex, the vertical aspect of the unit, sited within a shower wall void, and then the pump itself, that's the only part of a wastewater heat recovery system that isn't passive, that may need servicing. So we'd certainly recommend that being in a highly accessible location, for instance somewhere like a vanity unit in the basin. As we say there, offers the same high efficiency as that vertical Pipe Hex. Again, same additional products required: 2 full bore isolation valves, 1 double check valve, 1 drain off valve, and then your irons down to your recommended pipe size. So now we're going to look at the first of our horizontal products. This is the Easy Fit Plus. This is our mainly retrofit under baths and under shower trays product. So you can see in our display unit we have it here sited under the bath. Now this product will need a 90mm to 100mm installation height, so it fits quite easily under the void in the bath, and will also fit under a shower tray with a riser kit. One point to make straight off is many baths you'll find with a central leg. You may have to take this out and bridge it. We have a rocker bridging leg set there on our display unit, but we have looked into it and there are many other options there. So as you can see there when James moves the unit, you need a 30 to 40mm fall across the unit. The unit itself is just shy of 1200mm in length, so it's around 3 to 4%. So with this one, you need the same contraflow between the wastewater and the inlet. So if you have the inlet in the bottom corner, then the outlet has to go in the top corner. Similar additional products required. Again, the 2 isolation valves, your double check valve and your drain valve, and your 2 1/2-inch female lines, I should say, for the Easy Fit. Much again, you want to support the fittings when installing, not use excessive pressure. Off the back of the outlet for the waste, you'll see a push fit connection. Similarly on the inlet to the waste as well. One of the great things about this product is it is reversible. So it doesn't matter where your inlet and outlet connections are, it will work for you. So as you can see here, completely reversible, so whether your waste and feed are at the far end or the close end of the bath or shower tray, we can just turn it around for you. So I'm just going to have a quick look at the connections from the back, just give you a bit of a closer view. You see cold coming into the unit to the far end, takes that preheat out close to the thermostatic mixer shower, going up through the back, and that replaces your cold side feed. Okay, we'll talk about our final sort of product in the current range, which is our linear drain options. We have 3 linear drain options, all very similar in their installation. Sorry, got backed up with the cameras there. Right, so as we say, 3 varying options. In terms of efficiency, offering you between 30 and 45% efficiency. So you see you have the grate on the top. We offer 2 different types of grate, either a tiled grate or the stainless steel quadrato. Underneath that, the water then will go through onto the percolation plate, where you see you've got specific droplet outlets there to go through the heat exchanger itself. This is on legs. Again, you want to make sure that this is mounted level through the unit. There we go. In terms of waste outlet options, we have either a horizontal or a vertical outlet adapter for if you're going straight through and down vertically or across horizontally. Same as I keep saying, with all wastewater heat recovery products, you're going to require your 2 isolation valves, drain off and double check, and these you want to site those in a reasonably accessible location and practicable. Superb. So that's kind of it for me. I'm going to hand over to my colleague James. What I will say is 2024 is going to be a very big year for Recoup. We were taken over by Myra Showers in the middle of last year. We've got some great new product developments that are earmarked for 2024. Going to offer you great options for retrofit, for new builds, for single story dwellings as well. So at this point, I'm going to pass over to my colleague James.
Microphone's on. Yes, excellent. Yes, so I'm James. I'm here as a technical support engineer or service engineer. Plumber of 19 years, so was brought into Recoup last year as their resident plumber to be able to speak the language with the installers and support you along your installations. I'm also going to deal with the product returns. So any issues on site, we ask that the installers contact me and see if we can resolve it there and then. If not, it gets returned and we have a look at the product and I deal with the whole return process. So I'm here to speak to you about some installation methods, look at some schematics and talk about some technical bits. Hopefully if you have any questions at the end, we'll be able to answer them as well. Hopefully it'll get you thinking and we'll see if you've got any questions at the end. So I'm just going to play this video. It's a little video I made. If you have been online on the website, you probably will have come across this video and seen it already. But for those of you that haven't, we can have a little play of that now. If I can just press a couple of buttons on the side here. The full range of Recoup wastewater heat recovery systems can be installed in System A, B or C configurations, giving options for installation with various efficiencies. With each of the products and system types, the efficiency will also be affected by the shower flow rate. Design shower flow rates must be observed. This video will look at each system type using a single shower feeding into a pipe hex. Multiple showers can feed into a single wastewater heat recovery system with further guidance available on the website. With all system types, the connected shower must be a thermostatic mixer shower with balanced mains pressure supplies. System A supplies preheated water to the cold feed of the thermostatic mixer shower and the cold feed of the water heater. The water heater can be a combination boiler, unvented hot water cylinder of any heat source, thermal store or heat interface unit. System A is the most efficient system configuration, offering up to 60% energy reduction. However, if more than one wastewater heat recovery system is to be installed in a property, only one can be supplying preheated water to the water heater. Additional units must be installed as System B configuration. System B supplies preheated water to the cold feed of the thermostatic mixer shower only. It is the least efficient system configuration, but still reduces energy consumption by around 50% with a pipe hex installation. It is typically only used on secondary wastewater heat recovery systems when more than one is installed within a property, or with retrofit installations where major pipework alterations are not feasible. System C supplies preheated water to the cold feed of the water heater only. It is the middle efficiency system configuration, and just like System A, only one wastewater heat recovery system can supply preheated water to the water heater, meaning additional units must be installed as System B configuration. System C is the least common, and is usually specified where the pipework length between the wastewater heat recovery system and the shower valve would be more than the maximum 4.75 metres, preventing a System A or B installation. An example of this may be a townhouse with one bathroom above another, with a pipe hex on the ground floor. 4.75 metres pipe length in 15mm copper is to limit the volume of preheated water that is left in the pipework between showering, maintaining a low Legionella risk. The preheated water pipework volume between the wastewater heat recovery system and the water heater is not a concern, however, as the water heater should be set to increase the temperature to above 60 degrees Celsius. Where SAP calculations have specified the system type for the wastewater heat recovery installation, this must be followed, as failure to do so could mean the property does not comply with Building Regulations Part L or its energy efficiency requirements. Hello, good. So that's saved me talking a little bit. So some of the key points from that video, A, B and C recognised installation methods within SAP. Only one is A or C, so feeding the water heater. The reason you can't have more than one is that you can't ensure that water will be pulled through both of them during operation, so only one as system A or C. You can have multiple showers, as it said there, which is another little video we're going to come into in a second. Must be thermostatic, install as the specified type, and the 4.75 meters we will come on to again in a bit more detail at the end. And the shower flow rate, it does affect efficiency. As you can see some efficiency figures at the bottom there, depending on the flow rate. A lot of showers now are 8 litres per minute, sort of a standard maximum flow rate on showers. But you can see there, if you drop down to 5, I think this is the pipe hex on a system A, gets you a system efficiency of 79.3. So we can, as I said, and I said in the video as well, have multiple showers with wastewater heat recovery systems. So another video for you on that, just to save me talking over it again. Where multiple showers are located close together or above each other within a property, it may be that they could benefit from energy savings while being connected to just one single wastewater heat recovery system. The limitations would be the draw-off length between the wastewater heat recovery system and the shower valve, and the design shower flow rates. When connected to System A, the maximum combined shower flow rate is 16 litres per minute, as the wastewater heat recovery system is supplying preheated water to both the shower cold feeds and the hot water source. If a flow rate greater than 16 litres per minute is required, and any SAP calculations that may be in place allows, then a System C configuration could be considered. With the preheated water supplying only the hot water source in this case, the combined shower flow rate can be up to 24 litres per minute. If the hot water source is a considerable distance from the wastewater heat recovery system, then System B configuration could provide a solution to supply preheated water to the cold feed of the showers only, again allowing for a combined shower flow rate of 24 litres per minute, but with a lower SAP score and efficiency. As with the single shower installation, preheated water pipework between the wastewater heat recovery system and the shower cold feeds should not exceed 4.75 metres total length in 15mm pipework. Wastewater pipework from each shower into the wastewater heat recovery system should not, where possible, exceed 3 metres to minimise heat loss before entering the wastewater heat recovery system. Multiple wastewater heat recovery systems may be required where multiple showers are installed within a property but are not close together. Only one wastewater heat recovery system can be connected as System A or C system configuration, and additional units should be connected as System B configuration. Consideration should be given to which shower we use the most and their distances from the hot water source when choosing the primary shower to connect as System A or C. Please contact us if you need additional information or guidance on multiple showers being installed within a property with wastewater heat recovery systems. Okie dokie. So, let me just find my cursor again. Here we go. Oh. Magic. So key points from that one. If a shower's close together, they can connect into one wastewater recovery, maximum 3 metres of waste pipe work. But we do have to consider the draw-off length on the preheated side, maximum of 4.75 metres again. Shower flow rates there, just to observe, just to limit the amount of water going through. The faster the water's flowing through, the higher the pressure drop, ultimately. And yeah, where they're not installed close together, you can have more than one within a property. So let's look at some schematics. We've got a System A installation here with a cylinder. So a little bit different to a standard cylinder installation without wastewater heat recovery. The main point being the balance cold pipe work. So you can see here at the cylinder combination valve, the balance cold draw off has been capped off. And the reason being, if we're supplying preheated water to the cylinder, we can't be drawing that out to the cold outlets. So we cap that one off, and you can see on the right hand side of the drawing, your mains coming in through the stopcock double check valve, standard drain off valve setup, additional pressure reducing valve at that point to then be able to take your balance cold off after, before then going a supply to your wastewater recovery, and obviously the balance cold out to your cold outlets. System B installation excuse me, takes it back to more of a standard setup with the cylinder. So still want an additional pressure reducing valve on the cold main after as it comes in, just to balance out the pressures in the property, make sure everything's under control. So then, yeah, a main supply to the cylinder as per usual. You can use that for your balance cold draw offs at the combination valve, because we're just taking a supply to the wastewater heat recovery to supply the shower. And in that case, that pipe work supplying the wastewater heat recovery can come from the same bathroom. It hasn't got to be a dedicated feed from anywhere. Just tee off the cold pipe work within the bathroom, have your isolation valve double check valves on, and then supply up to the shower. So probably a bit more simple. System C installation, obviously very similar to the A, but not feeding the shower, so it goes back to this setup of not using the balance cold connection of the cylinder and having the balance cold water outlets being supplied from back before the wastewater recovery. So got this drawing here made up. There's sort of some suggested valve locations and a couple of options on supplying. So we've taken away the cylinder in this case, and this could be to a combination boiler or any other of the heat sources. So it's just showing there as a water heater is on the supply of the preheat. But ultimately what we've done with this drawing is indicated on the right hand side there. These valves, this sort of valve arrangement and the draw off to the balance colds could potentially be done under the kitchen sink. So it's quite nice to have that all there, all the valves in an accessible location under the kitchen sink, and then run a dedicated supply to the wastewater heat recovery and then off to the shower and or water heater. And then obviously a separate balance cold supply out to the cold outlets. So it's quite a nice way, like I said, of getting the valves, the inlet valves and everything, that arrangement in a nice accessible location. With the outlet, also the preheated valves, there's a couple of options there that can be suggested. So option one is sort of our standard arrangement of one isolation valve before the tee off to the shower and the water heater. But what you could potentially do is to not have that, or to make that more accessible, the isolation element of that more accessible, is to have two separate isolation valves, one perhaps at the cylinder or the inlet of the boiler, and one isolation valve on the supply to the shower. So if it is a case of isolating and draining the unit for whatever reason, there will be more water to drain off in this case, a bit more water wasted, but it can get around issues such as access to the valves and having to put in access hatches within boxing and stuff. So this around that is not necessarily been approved by any of the house builders, if any of you are working for the house builders. If you've got M&E designs by them, I will say at this point it does have to be followed. You could perhaps speak with them and suggest workarounds with them based on this sort of drawing, but it's not necessarily been approved by anyone. But certainly if you were doing anything for a private sort of customer, one-off builds or anything like that, this sort of arrangement you could adopt, and it works quite nicely. So with the big house builders, an example of what you'd tend to see or would expect them to be sending you on your M&E drawings here. So you can see on this case, I'm just going to quickly look upstairs because I can see it a bit easier. So this case has got the arrangement of the cold main coming in with the double check valve and everything, and additional pressure reducing valve on the cold main. It supplies the kitchen sink before then, on the outside tap, before then rising to above. So it then goes over the top, and you can see at the bottom there a wastewater heat recovery system at that point. So once it's gone into the ceiling, however, initially, That's where the split is in that case, to then have the balanced cold supplies. And you can see the supply coming all the way through past the cylinder, so where it's coming from from below at the kitchen point underneath the bathroom. You've got two supplies, one feeding the cold and one feeding all the way through to the wastewater heat recovery before then being preheated, coming back up, drawn in pink, to then supply the shower and the cylinder within the ensuite and the cylinder cupboard. So it should be relatively clear. Some good pipe sizes are indicated on there and stuff. So this is, like I said, a good example of what you might expect to see for tendering and obviously installation. Outside of that, if you've got any customers, smaller house builders that need a bit of guidance to include wastewater heat recovery, if they've got plans without it indicated on things, you can send them over to us and we will be able to indicate where potentially some of the units could go, what unit type could be used, where it could go, what it connect to, and this is an example of sort of what we send back as suggested wastewater heat recovery. So a few things to discuss. This is based really on speaking to installers, a bit of feedback and things they want clarification on. So the connection into our products are all 1/2 inch, and we are aware that there is a pressure drop across the units. So the 1/2 inch connection size, I've been questioned, why can't you make it a 3/4 inch? If you putting 22mm pipework to it, it should be a 3/4 inch connection. But ultimately, you can see in the picture at the bottom there the cutway through the pipe hex. So as described obviously a little while ago, the wastewater passes down through the inside of the copper section there, so right bang in the middle, and the cold water being preheated passes up in the gap between the copper heat exchanger and the PVC outer. So that space between those two elements there is very small. That's what creates the pressure drops. It's not to do with the 1/2 inch connection size. If we put an inch connection on there, it would still have the same pressure drop. So the reason that is so small in between there is to limit the volume of water passing through, so that we get a more efficient heat exchange. If that gap was massive and there was loads of water in there, ultimately it's just not going to heat up as well. So it's a bit of a balance between pressure drops and efficiency ultimately. So I mentioned as well before, the higher the flow rate through the product, the larger the pressure drop. So it sounds dramatic, but really it isn't. We've got a 9.2 litre per minute flow rate. This is for the pipe hex. Will, with the system A, create a 0.39 bar pressure drop. So it's not a huge pressure drop in having installed the products retrospectively to in a property on a system A with a cylinder. Having a visual and checking the flow rates on the outlets of the hot without wastewater recovery and then with the wastewater recovery in place, there really isn't any difference. It's not a noticeable difference certainly on what you get out of the tap at the end. So pressure drop across the unit is not too much of a concern. Connecting to the turbo, so a couple of installers come back and said it feels quite loose in there as you're inserting the pipe into the turbo, but it's got a 60mm insertion depth into the turbo, so just recommend that you put plenty of glue on for the first 60mm of the pipe, give it a good twist as it goes in to get a good seal on there. Now the other thing to note around that is looking at the turbo, it can be mounted either way up, and you've got an O-ring seal that seals it either into the top of the pipe hex or for the cap going on the top. But as it goes into the pipe hex, it passes possibly 20mm into where it seals onto into the copper side, into the copper pipe of the pipe hex. So just make sure as you're installing the pipe work that it does remain flush with the top of the pipe hex. It's fully inserted. If it's on the wonk, you can potentially sort of ruin that good seal that you have with the O-ring. Insulation and labels of the preheat. So all preheated pipework needs to be insulated for its entire length, and I'd say to insulate it with the same thickness and quality of insulation that you're insulating the hot and cold pipework within the property. Preheated tape we do supply from merchants and direct, should you wish, to buy our preheat supply tape to label the pipework. Should be done every sort of metre, changing direction or points where it becomes concealed, just the same as labelling for other pipework. Point there that has been raised already by Chris, but not to insulate the wastewater heat recovery system. And yeah, if you're passing on the installation before boxing, just if you get the chance, just note that to the person doing the applying insulation to the soil vent pipe. Pressure testing, 10 bar maximum test pressure. I know some of the pipework being installed needs testing to a pressure above this, up to 18 bar in some cases. So all you say is to take it up to 10 bar, and with the inlet and outlet isolation valves that have been installed, just isolate at 10 bar before further increasing the system pressure. Before turning the valves back on, just make sure that increased pressure is released, back down to at least 10 bar before you turn them back on. However, once you've isolated the product, there is a chance that the preheated pipework will also then be isolated, so it might require some linking over of pipework within the cylinder cupboard or something, just to link and to increase the pressure of the preheated pipework test. Drain testing. So drain testing is obviously carried out on new build properties. I would recommend an air tightness test as opposed to a water one. It just seems a bit more gentle and a bit more accurate. So air test is certainly what I'd suggest as a preference over water testing. So pipe size and preheat to the shower. So this is the 4.75 meters in 15mm pipe to the cold feed of the shower. So it's been mentioned a few times. So ultimately, we had a third-party risk assessment on all of our products, and with Legionella assessments on properties, it's all about the ability to have cold water below 20 degrees at the outlet within a metre of the tap or outlet running. So with our products, it was deemed that the pipework between the wastewater heat recovery in the shower, if that volume is kept very low, then as the shower is operated, it will obviously then purge that out fairly quickly. So 4.75 metres in 15mm pipe is a volume of 0.69 litres, so 700 millilitres. So that will quickly be pulled through. What I would advise is taking the T, if it's a system A, is to take the T that goes up to the shower fairly close to the wastewater heat recovery system. If you run it across in 22mm pipework from the wastewater heat recovery across the bathroom before teeing up, as shown on the right hand side within a couple of metres of 22mm pipe, you've already used that volume of water, equivalent of the 15mm. So if you're increasing the pipe size, increasing the pipe length, you would require just a separate Legionella risk assessment on the installation, because it would just fall outside of our third-party Legionella risk assessment that's in place that deems the every installation of all our wastewater heat recovery systems as a low risk, the same as any other shower installation, a regular shower installation, if you like. So there's loads of information on the website. Those videos that I shared and more are available on the website. All the product installation guides and everything else is all available to download, so most of the things that you need to know can be on there. There is a knowledge base as well that we've set up, so hopes to cover off a lot of the questions coming in. So there's a search bar. If you go onto the website, scroll right down to the bottom and you'll see the button for the knowledge base. A little search bar in there, you can type in your questions and thoughts and it will bring you up some articles that will hopefully cover give you an answer to your question. If not, obviously email in and we can sort you out. So this CPD, the other CPDs and all the videos that have been created are all put onto YouTube. So have a look on there, you can look back at previous CPDs and everything if you can't make any more of these at the given date and time. So yeah, they're all available on there, loads of videos. All about CPDs, so feel free to obviously join the others. They're all free if you think they might be of interest to you with retrofit and new build and SAP and everything else. We have a learning site on the website which is due a bit of an upgrade, a bit of an update, so going to be doing that soon, but you can run through there and there's questions and bits and bobs that sort of increase your understanding of wastewater heat recovery. This is where we have been today, Chris and I, and it's particularly useful and has been if somebody calls in, just needs to understand something particular about one of the products. We can come downstairs into our room here, switch on the cameras, and as we have with the GoPro, get up close with the products and show things. So it's quite a useful space. All of our products are stocked, certainly the pipe hex and easy fit are stocked at the main merchants. Product codes are listed on view here now, so if you need them immediately, do feel free to take a quick screenshot and just grab hold of those. But yeah, the product codes for pricing and everything else. So we don't sell direct, or don't really tend to sell direct at all, only really through merchants. So get quotations and procure your products through those. This is me and all my details. So my direct number and email address, and like I said, I look after the installers. So this being the installation CPD. Hopefully this has been relevant to you, and my details going forward. Any issues with anything on site, if you're engineers that perhaps might work for you, feel free to pass these details on to them. They can give me a call from site if there's any issues, and like I said, any problems with products, they come back to me, and yeah, I deal with those. So these are my details here, so catch those if you wish. So following this, we will send out a feedback form, and ultimately on completion of the feedback form, send it back to us. We do what we call CPDs for trees. So for every attendee that has joined us here today, and all of the other CPDs, we do sponsor or put money towards the development of wildland and forest areas. So trees and such be planted based on attendance to our CPDs. And that is it. We've made it to the end. So if you have any questions, I don't know if any popped up in the chat along the way. I don't know if Craig can hear and see any questions that might have come in already, but
nothing in the chat.
Nothing in the chat, magic. So if we have any questions, we are going to stick around for however long we need to, but certainly a couple of minutes. If you've got any questions, do fire away.
A question in the chat, James, regarding how much noise the systems make. I don't know if you can answer that one.
Sorry, I was muted then. Yeah, noise levels is definitely well. The only really one of note, I would say, would be the pump of the pipe hex active range. I can't remember off the top of my head the decibel rating, but it is quite low. We can provide you with further details of the decibel rating of the pump. But for the standard unit, the pipe hex and the other sort of passive wastewater heat recovery system products, I would say the noise is not worth noting. Certainly not a figure that we've tested and had to put in our instructions and technical data. So obviously it would depend on flow rate. So if you're trying to blast 30 litres per minute through it, it will make more noise than a sort of a more sensible flow rate.
Just another question, James, about compatibility with prefabricated bathroom pods.
Prefabricated bathroom pods, yes, we've been included with some of those, I do believe. I think, in fact, Craig, you might have had a bit more dealing with that than myself.
Yeah, we have had products. I think Easy Fit most is the one that usually gets spec'd in with bathroom pods. We've got some examples of where that's been used on some student accommodation projects, where the Easy Fit has been designed to fit under a shower tray, and on occasions where the shower tray isn't quite big enough to accommodate it fully in terms of the width, because it does require a larger shower tray to fit under. It's then been accommodated within kind of a service cupboard or pod to the side. So yeah, they are compatible with prefabricated bathroom pods. Just obviously it just needs to be designed to accommodate the size and dimensions of the unit. So the Easy Fit, the horizontal kind of under bath shower tray product, is the one that usually gets spec'd in for that kind of thing. But there's no reason why maybe the active pipe couldn't also be used in a bathroom pod potentially. The active is a newer system, the pumped active pipe hex unit. So I haven't got examples or case studies of that where it's being used yet, just because it is a newer product. So, but yeah, definitely the Easy Fit has been designed into bathroom pods previously.
Magic, thanks, Craig. Magic. So, I guess we're all happy there. So, if you think of anything else any questions when you get off the call here, then just you can feel free to email in. It could be to myself if you took the details off the screen there, or info@recoup.co.uk. And yeah, we'll be able to answer off any questions that you might have. And feel free, like I said, to join any other CPDs. But thanks for certainly coming along today. Thank you.